Hello, welcome to another lesson. So today we're going to explore this sort of cool method of dividing polynomials called the synthetic method. Now, we know that whenever we're dividing polynomials, it takes quite a long time because we're trying to replicate the long division method that the long division approach that we sort of saw in year 6, year 5, where you basically do it in iterations to get down to a remainder. So I'm going to do a few questions with that old process. Of long division, and then I'll show you the cool new sort of hack, which is a synthetic method. Now, of course, the disclaimer is that if you wanted to apply the synthetic method at school, ask your teachers whether you can, because some teachers are big on the working out that is involved with division of polynomials. But if your teachers are cool and you want to save some time in a test, feel free to use the synthetic method. Now, the synthetic method doesn't cover all cases. It only covers cases where you divide by a linear expression. So just letting you know, that's the best application for it. So let's do this. Polynomials. Division. Now we know, so traditionally, let's just dive right into it. There's no theory that needs to be done. So if I say to you, evaluate, in other words, find the value, let's do the first example. I'll give you a polynomial, x squared plus 4x squared, sorry, x cubed rather, let's do a cubic, x squared plus 3x minus 5. If I ask you to divide that by, let's say, a divisor of ax equals to x plus 2, right? So if you were to do this using the old method, let's do it quickly. You basically set it up where the divisor, or the ax in this case, divides into the given polynomial, which is x cubed plus 4x squared plus 3x minus 5. Now, traditionally, you basically ask yourself the question, so what do I multiply with x to cancel out or to make it look like x cubed? So obviously, that's x squared. And you sort of do this in 4 steps, right? Identify the x squared, multiply x squared to the divisor. So you sort of get like x cubed plus 2x squared, line it up. Third step is that you subtract, right? You subtract, which gives you, that guy goes away. That's the whole purpose of selecting that guy in the first place. 4x squared minus 2x squared, that's 2x squared. Bring down. So step 1, identify x squared. Step 2, multiply. Step 3, subtract. And then step 4, bring down the next term to do this again. So ask yourself, what do I multiply with x to get rid of, to make it look like 2x squared? So that's 2x, because 2x times x is 2x squared. Then 2x times x is 2x squared. 2x times 2 is 4x. Step 3, right, subtract that. So 2x squared minus that goes away. 3x minus 4x is negative x. And then step 4, bring this guy downstairs. So what do I multiply with x to cancel with negative x? So it'd be negative 1. Negative 1 times that is negative x. Negative 1 times 2 is negative 2. Once again, subtract that, right? Now be careful here because there's a lot of negatives. Negative x minus x, that goes away. Negative 5 minus minus 2 is negative 3. And that is my remainder. Basically, if you get to a point where the power of your expression there is smaller than the power, or if you use a technical term, the degree of your expression there is smaller than the degree of your divisor, you stop, right? You're done. So your conclusion is therefore px, if I divide that by ax, that gives me my quotient plus my remainder. Now, if the remainder is negative, in this case, make it 3 divided by the divisor. Yeah, so that's all well and good, right? And that's my answer. Yeah, it took me quite a while. Yeah, so I have done this a few times, and that took me about 1-2 minutes. At school, that might take you about 2-3, depending on your speed. Let's explore the synthetic method, right? So maybe I'll call this method 1, yeah, aka traditional, and then method 2. Yeah. So this is the synthetic. So whenever you hear synthetic division, I just spelled that wrong, didn't I? Synthetic method. So whenever you hear synthetic division or synthetic method, they refer to this really neat, quick way of doing it. So this is the process. We basically draw ourselves a angle as such. All the coefficients are on the polynomial. So 1, 4, 3, -5. I'll write those down. 1, 4, 3, -5. Right? Now, this is the plan. If I'm dividing by x plus 2, right? X plus 2 in this case, yeah, I'm going to put in the opposite of plus 2, so -2 here. And that's going to form the basis of my my synthetic. Now, synthetic is ultra easy. So check this out. Now, there's always put a 0 there, right? You start with 0. For each of these numbers, this is a two-step process. I'm going to times, add, times, add, times, add. Watch this, right? So add, right? So maybe I'll put a little plus here. So remember, times, sorry, in this case, add times, add times. I'll show you what I mean by that. 1 plus 0, 1. 1 times, right? 1 times -2 is -2. So add times, add times, always times with -2. Add times, add. You're done. Now, you got 1, 2, -1, -3, and you're thinking, what did you just do? You just got the answer because the last digit, right? The last digit is always the remainder, -3. The ones before that are the coefficients of your quotient. So you can actually look at the synthetic and go, therefore, px divided by ax is equal to, now if you know that's your remainder, you know it's a cubic to start with. So this is a quadratic, x squared plus 2x minus 1, and then remainder of x plus 2. Oh my goodness, how quick is that, right? So add times, add times, add times. And then you got it, the coefficients of your quotient and the remainder itself. Yeah, let's do another one, right? Let's do another one. Synthetic method, ultra fast for dividing polynomials, right? Let's explore another one. Yeah, let's explore another one. Now this one here might get a bit, let's do a nice big ugly one. So if I said to you, the polynomial originally was 2x4 plus 9x cubed. No, that's a bit too ugly there. 3x cubed. Yeah, minus x squared minus 4x minus 5. And let's divide that by the divisor of x minus 3. So once again, let me do the traditional way and then synthetic side by side, right? So just so you can compare. So I'll write this down in method 1. Yeah, so traditional. So let's do this again. So I'm dividing, my divisor is that, my polynomial is this. So let's go through that 4-step iteration process, right? Step 1, I say to myself, something times x gives me 2x4, so that's 2x3. The moment you write that down, step 2, multiply it in. 2x4, 2 times -3, -6x cubed. Then the subtraction, that minus that goes away. 3 minus -6 is 9. Step 3 done. Step 4, bring down the next term to minus x squared. Pretty straightforward. Put a number there, so plus 9x squared to multiply with this to get rid of that. So 9x cubed there. 9 times -3 is -27. Now the numbers get a little bit large. And then I subtract, that guy goes away. Minus x squared, minus 27, so that's 26 squared. Step 3 done. Step 4, bring this guy down. -4x. Next loop. So plus 26x there to multiply with that to get rid of that. So 26x squared. 26 times 3, what's that, guys? 78 or -78 in this case. You can check that with the calculator. That guy goes away. -4 minus, so plus 78. What's that? 74x. Step 3 done. Bring down the next number. Now numbers will get quite large here. So let's see. Plus 74 to cancel, multiply with x, cancel this guy out. So 74x. 74 times 3, what's that, guys? 222, I believe. Then minus that guy goes away. -5 plus, because minus 20, 222 is 217, and I stop there. So it looks like that's my answer. Now I won't put the conclusion because I'll do it with a synthetic and put one conclusion so I don't double do it. Yeah. So that's my answer. So I'm hoping that my synthetic gives me 2, 9, 26, 74, 217. Yeah, that's my aim. So I have space to do it down here. Let's do it down here. Actually, no, I want it side by side so you can actually see the answer. So let's go method 2. Yeah, let's go synthetic on this. So once again, draw your angle. I know it's -3, so it's +3 here. And put the coefficients of the question 2, 3, -1, -4, -5. And then remember, start with a 0. And I'm going to add times, right? So add 2 times 6, add 9 times 27, add 26 times 78, add 74 times 222, add 217, done. 2, 9, 26, 74, boom. 217, boom. Right? So your answer is therefore px divided by ax is 2x cubed, 9x squared, 26x, 74, plus 217 on divisor. Guys, what do you reckon? Right? What do you reckon? It is absolutely up to your teacher whether they would accept that, but you know, at the end of the day, if you get the answer, I'll put it to you this way. Even if they don't accept it and you got to do it the other way, the method 1, the traditional way, I do traditional and then use this as a really strong check, right? Just to make sure you've done it right. I mean, another strong check obviously is to use the remainder theorem to sub in the value of 3 in this case and get the remainder of 217, but this is almost like a secondary check to it. Yeah, cool. Let's do one more, right? Just to demonstrate point, and it'll be a very short video. Yeah, very short video. Let's do one where there's a lot of gaps, right? Zoom out. That's cool. Let's do one where there's a lot of gaps. Yeah. So, part C. If I said to you, let's say px equals to 2x5 minus 6x squared minus 1. So lots of gaps. Let's do it. Ax, x minus 1, just to make it easy for us. So lots of gaps in that. There's lots of missing polynomial terms like x4, x3, x. So when they're missing, as we do in the traditional method, we basically put in zeros. We'll do that for the synthetic as well. So let's go here, method 1. So the traditional way, you basically set it up as you would. x minus 1 dividing into, now every time you see a gap, just remember to put in 0, right? Or 0, whatever that x value is. So I've got 2x5. I don't have any 4s and 3s, so then I'm going to add 0x4, 0x3, then plus, oh sorry, minus rather, 6x squared. Now there is no x, so plus 0x, and then minus 1. And here we go. So put in a 2x4 here to cancel, times with the x to cancel this guy out. And times that 2x4, step 3, subtract. Oops, sorry, that's a 5. That goes away. 0 minus minus 2 is 2x4. Step 4, bring this guy down. That's a 0. 3. So I'll go again. I plus 2x cubed to times with the x. That times with negative 1 is negative 2x cubed. That goes away. And we go again. Step 4. Bring this guy down. To, sorry, I forgot the minus. So 0 minus that. That's 2x cubed minus 6x squared. Perfect. Plus another 2x squared. Step 2, multiply this guy with this. So minus 2x squared there. Step 3, minus negative 6 plus 2 was that minus 4x squared. Bring down to 0. So minus 4x there. So I've got minus 4x squared plus 4x. Step 3, subtract that. 0 minus 4 is negative 4x. Almost there, guys. One more. All right, almost there. One more. Have I done that? Have I done anything wrong there? Let me see. Minus 6. Minus 6. No, that's fine. Minus 4. Bring down the negative 1. So that's another minus 4. Is that right? 0. So I'm just checking the maths. Yep. The example that I gave that I'm trying to copy off, I actually did a plus, so I'm sort of doing not comparing like or like. Now that's fine. So 0 minus 4. Perfect. Okay, let's do this. I'll do a quick check later on just to see using remainder theorem anyway. So minus 4 times that minus 4x. Perfect. Minus 4 times that plus 4. So guys, did you get a remainder of 3? Yeah, so the remainder, remainder 3, let me just use the remainder theorem as I alluded to previously. So using the remainder theorem check. Yeah, so if you were doing a test with division of polynomials, right, here's what you do, right? You basically sub in the value of 1. So if that was negative 1, subbing 1 into that, get 2 times 1 to the power of 5 minus 6, 1 squared minus 1. See what we get. I've got 2 minus 6 minus 1. What's that? That's minus. So I've done something wrong clearly because the remainder is not 3. 2 minus 7. That's minus 5. Quickly debug. Right? Everything looked right up until so minus 6x squared. Minus, that's minus 4. Minus 4 up here. Plus 0. Minus 4. Plus 4. That's negative 4. Negative 4 again. Bring down to negative 1. Minus 4 plus 4. Oh, this is minus. Yeah, so if that's a minus, yeah, that would be minus 5. Perfect. Yeah, here you go. See, nice little check. Yeah, I like to say I did that on purpose, but I didn't. But now it's fixed, right? Thank God for that check. So hopefully, if I use a synthetic, I would have got that check anyway. So let's see, right? Method 2. Yeah, like sometimes you see videos that are edited and they don't make any mistakes. Yeah, I just showed you reality, right? Sometimes it's actually better to see people make mistakes and see how they fix it. Because if you were to buy a textbook, you don't actually get that element, right? You just get the final answer, you get the perfect working out. It's always good to see, because mistakes happen in life, right? When you're doing a test, it does happen. It's always good to see the process of debugging it and trying to find the errors, etc. Right? So yeah, I'd like to say that I meant that as those mistakes as part of the video, but no, I didn't. But there it is, bonus. So I want to put these guys in. So it'll be 2, 0, 0, because they didn't exist on my original, and then it'll be -6, 0. Yeah, -1. I like to put the zeros in a different color just to show you that it wasn't part of the question, but I'll just put it in. So then x minus 1, put the 1 there. Right, remember, the process is add plus. Oh, sorry, add times, add times, add times. So start with 0 then. This is really easy, right? Add times, because it's the 1, right? Add times, sorry, 2 with 1. Add times, add times, add times, add, done. 2, 2, 2, negative, boom. Remainder of -5, boom. Right. So it's almost therapeutic, right, to do it this way. So px divided by ax equals 2. Now, it wasn't x5 to begin with, so that one there is 2x4, 3, 2, 1, constant minus 5 on the divisor. Is that okay, guys? So, a cool method for us to use when dividing polynomials, right? Just to make another check. You can use a remainder theorem check as a check on the remainder, but another method that you can do, if your teacher allows you to do it, man, I would jump on this in a heartbeat, because you will get questions done in a heartbeat. So if you like that, subscribe if you haven't already done so. Give me a like, tell your friends. I'll see you guys next time for another video. Okay.